Hey, we're back again, starting section 3 now, solving systems using substitution. Okay, this method is much more exact than graphing. Graphing is so inexact that I'm not even making you find the answer. I'm just making you circle where they intersect. But when we do substitution and the next one is elimination, we will be finding the exact solution. So, substitution, when do we want to use that? It's best used when one equation is already solved for a variable or when there's a variable without a coefficient. Okay? All right. Hang on one second here. I had to pause it for a brief minute. So let's see. Yes, it did come back up. Good. Okay, so it's already solved for a variable or when there's a variable without a coefficient. As with graphing, we can still get one, none, or infinite solutions. Okay, and we're going to see an example of when we get each of those coming up here. Okay, so when we have one solution, that means just like with the graphing, it's x equals some number and y equals some number. Okay, no solutions is when both of these together actually, your variable is going to cancel. Just like the last section when we were solving cancel. I don't know how to spell cancel, sorry. When your variable cancels, I don't think that one's right. Let's try it. That one's right, I hope. When your variable cancels, the no solutions is when you have a false statement left. Infinite solutions is when you have a true statement left. And like I said, we'll see an example of those in just a minute. So let's get into our first example. Y equals 3x and x plus 2y equals negative 21. You can see that we have a variable that's solved already. It's already solved for y. Okay? So what we need to do, substitution, means I'm going to take what y is equal to, in this case it's the 3x, and substitute it into the other equation for y. So my bottom equation becomes x plus 2 times 3x is equal to negative 21. What this allows us to do, then we can do 2 times 3x, but what this allows us to do is now we have an equation that only has one variable. We know how to solve equations that only have one variable. Okay? Divide by 7, and x is equal to negative 3. Now we have x. I'm going to have to substitute again back, and it doesn't matter which equation you pick, but you're always going to want to pick the one that's easiest. Okay, so I'm going to substitute back into this top equation this time because it's going to be much easier than substituting it into the bottom equation. And y is equal to 3 times negative 3, which means y is equal to negative 9. So we had one solution there, x equals negative 3 and y equals negative 9. If you were to plug those back in, you would see that you would get true statements for both of those equations. Okay? So that's the entire process. Let's try another example. This time, I don't have a variable that's already solved for. So what I can look for is something like this x right here, where there's no coefficient in front of it. It'll be very, very easy to solve for that x because I don't have to divide by anything. All I have to do is subtract 5y. So that x is equal to negative 5y minus 3. Now, I can take what x is equal to and plug it into this equation for x this time because x is equal. Okay, so 3, don't forget parentheses because we're going to have to distribute to this entire phrase. equals 8. Okay. Again, the parentheses, that's why we need the parentheses. If you don't have those parentheses, it's not going to work. You're going to end up with something really weird. Okay, distribute. Now we can combine our like terms. We have a minus 15 and a minus 2y. We can combine those to get a minus 17y. Minus 9 equals 8. Get rid of that minus 9. Negative 17y equals 17. So y equals negative 1. What do I now have to do? Take that negative 1, plug it in there so I can find x. So x is equal to negative 5 times negative 1 minus 3, which means x is equal to negative 5 times negative 1 is 5 minus 3. So x is equal to 2. Okay? Not too difficult. It's a little bit long. You got to keep track of where stuff's going and where stuff's coming. So it's very, very important that you stay organized when you're doing substitution and with elimination. You've got to stay organized and know where you're putting equations and putting things. Okay? So let's take a look on the back at example 3. I already have y solved for, which is nice, so I don't have to do that. I can just take this 3x plus 2 and plug it in for y. So I'll have 6x minus 2, don't forget parentheses, 3x plus 2 equals negative 4. Okay, now distribute. This is why I gave you all these problems at the beginning of the year that has a negative in front of your number. Distribute the negative 2. Negative 2 times 3 is negative 6x. Negative 2 times 2 is negative 4. 6x minus 6x cancels out. So all I'm left with is negative 4 equals negative 4. As soon as I get that, there are no values for x. I have to look to see, is this a true statement or a false statement? Negative 4 is equal to negative 4. It's true. Therefore, we have all real numbers for our solution. Okay? So you can guess what the last example is going to be. We should end up with something that gives us no solution. So let's see. I have an x and a y that don't have a coefficient. So I can go ahead and pick whichever one I want to solve for. You can decide. I'll go ahead and subtract x. No particular reason. Like I said, it makes absolutely no difference at all. One way is not going to be any easier than the other. But I'll solve for x here so that y is equal to negative x minus 2. I'll take that and I'll plug it in for y in the top equation. So 2x plus 2 times negative x minus 2. Again, without your parentheses, you're going to be up a crick. Okay, so 2x minus 2 times negative 2 minus 2x. 2 times negative 2 is negative 4. Again, we see right here, 2x minus 2x cancel out. So negative 4 equals 8. Negative 4 does not equal 8, in fact, so it's false, which means we have no solutions. Okay? I hope this makes sense. Again, it's a long process, just like elimination and just like graphing, but as long as you stay organized and work through the steps, step by step, plug in, solve, plug in. Oh, it disappeared. That's not good. Hope you had it. If not, at least you can rewind it. So, hope it makes sense, and we'll see you in class. Bye.